Warm welcome, students. We are discussing our first chapter, structure of atom. In the previous class we have discussed about the electronic configuration and Bohr model of atom and how we are representing a Bohr model. If you know the Bohr model, how can you find the number of proton, number of electron, atomic number, mass number, etc. we are discussed in the previous class. Today we are going to consolidate our chapter and also the last topic of this chapter we are discussing here. It is mainly related with isotopes. Okay, this is mainly related with the isotopes. So here we want to know about isotopes. What is isotope and what is the meaning of isotope and which are the elements that's included in the criteria of isotopes. Here we are going to discuss about three atoms. They are protium, deuterium and tritium. Protium, deuterium and tritium. So the Bohr model is there. 1 proton, 0 neutron. So on one shell there is an electron. This is protium. Then second one, there is a nucleus, 1 proton and 1 neutron. There is one shell, 1 electron. It is deuterium. Okay, and third one, nucleus, 1 proton, 2 neutrons and 1 electron. This is tritium. So protium, deuterium and tritium. Protium, deuterium and tritium. So these are the atoms we are represented here. 1 proton, 0 neutron, 1 proton, 1 neutron, 1 proton, 2 neutrons. Here the number of neutrons are different. There is no change in the number of proton. Okay, in all cases number of proton is 1, but here the number of neutron is different. So what is the difference there? The number of proton, that means atomic number is always 1, but is the mass number. In the first case it is 1 and second case it is 2 and the third case the mass number is 3. But in all cases the atomic number is 1. So atom that have proton is equal, that means its atomic number is same. Atomic number same, that implies it's same element. So same element in which the atom, their mass number is different. Such type of elements we are called it as isotopes. Atom of an element, same atomic number, but they are different in their mass number. Their mass number is different. They are known as isotopes. For an example, this is protium, deuterium and tritium is the isotopes of hydrogen. These are the isotopes of hydrogen, that is represented as H11, H12 and H13. So H11 protium, H12 deuterium and H13 it is tritium. So look at here, the mass number, the atomic number is same, that is 1, but the mass number is different. So these are the groups, they have also known as what? Isotopes. So these three are the isotopes of hydrogen. This is protium, deuterium and the tritium. Like that all elements have their own isotopes. Okay, all elements they are representing, they have their own isotopes. These isotopes are generally named on the base of their mass number. These isotopes are generally named on the base of their mass number. That means if you are considering carbon, there are the isotopes of carbon are carbon 12, carbon 13 and carbon 14. Okay, carbon 12, carbon 13 and carbon 14. That means these are the mass numbers of carbon. Exactly the representation is C612, C613, C614. That means the atomic number are same, the mass number is different. Same element, but the atomic number is same, its mass number is different. They are known as isotopes. These are the These are the isotopes of carbon. Like that the elements are named according to their their mass number. So isotopes are same atomic number and a different mass number. So another topic is there that's not in our syllabus. They are isobars. Isotope is there, isobar. Isobar is a slight difference. Same mass number, different atomic number. That means atomic number is different, mass number is same. They are known as isobars. I just again repeat, this is not in our syllabus. This is for as a purpose of extra reading. Okay. Then there is isotones. Okay, there is no depend on mass number or atomic number. If the number of neutrons are equal, they are known as isotones. Number of neutrons are equal, they are known as isotones. Isotone. Okay, then isobar. The first case we are discussed for our chapter, that is isotope. Okay, now we are going to discuss some isotopes and their uses. Some isotopes and their uses. The first use is for deuterium. The first use we are discussing here is for deuterium. Deuterium we are representing a symbol as H12. This is deuterium. This is used in atomic reactors. Deuterium is used in atomic reactors. Then carbon 14. Carbon 14 is used to find the age of fossils as a part of carbon dating, to find the age of fossils. Their age will be calculated by using the isotope carbon 14. That method is known as carbon dating. So carbon 14 is an isotope that is used for carbon dating, to find the age of fossils and pathologic age materials. Okay, the next one, it is phosphorus 31. Phosphorus 31 is used as tracer in plants. It's used as tracer in plants to know the transport of nutrients from root to leaves that can be identified, traces, by using the isotope. It is phosphorus 31. And the another two isotopes are iodine 131 and cobalt 60. Okay, cobalt 60, these are used. Okay, iodine 131 and cobalt 60 are used for identifying the tumor or cancer like diseases, especially for medical purposes. So these are using for medical purpose to identify and recognize and diagnosis of cancer and tumor like diseases. Then another one, it is uranium 235. Uranium 235 is especially used. Uranium 235 is especially used as a fuel in atomic reactors. It's used as fuel in atomic reactors. It is used as fuel in atomic reactors. Okay, so these are the isotopes and their uses. First one, it is deuterium. They are used in atomic reactors. Another one, carbon 14, it is used to find the age of fossils as a part of what? Carbon dating. Another one, phosphorus, it is used as a tracer in plants for the conveying of nutrients, for the transport of, recognize the transport of nutrients. Then iodine and cobalt, it is used as medical purpose for the diagnosis and for the curing of what? Tumor and cancer like diseases. Then uranium 235, that is used as what? That is used as fuel in atomic reactors. So these are the topics that we are covered in this chapter. It is mainly related with the chapter structure of atom. So students, all of you listen carefully. We have completed our first chapter and we have discussed many related things with the scientists and their discoveries like protons, electron, neutron, then nucleus, and different types of atom models. Okay, especially planetary model and Bohr model of atom. Then how can you represent the Bohr model and the protons, electrons, neutrons, electronic configurations, etc. we are discussed. Today we have discussed the topic related with isotopes. And what is isotope, which are the examples as part of isotope, and how can you represent an isotope, what is the difference In which particle will be different in a case of isotope. Their number of protons are equal, but the number of neutrons are different. So that's why the mass number is changed. Same atomic number, different mass number. They are known as isotopes. Then there are examples and the uses of isotope. What are the uses of isotopes we are discussed here also. Okay. So students, we are completed our chapter and thank you.